This is lesson 12. It's trigonometry day 2. So I'm going to do this in 2 parts probably, hopefully just 2. So I hadn't taught you the 45, 45, 90. So I briefly discussed it in one of my previous ones where we had a problem that included, but I teach it with hashtag. And this comes from Eastside High School. Shout out to my Lancaster people in California. This was just a great way that students learned how to solve. Basically, if whatever's across from the 45, so it's like whatever's across from the 45, whatever's across from the 45, and whatever's across from the 90. We would use this called hashtag math. It used to be tic-tac-toe math, but you guys don't play tic-tac-toe as much anymore. So let's say again we had this 45, 45, 90 is x, x, x rad 2, and I promise if you keep writing that down every time you do an assignment, you will memorize it. But right here across from the 45, you can see that I would have 5. If this x is 5, then this x must be 5, and this x must be 5 and rad 2. So what it's saying is across from the other 45, which has to be right here, this one also is 5. And across from the 90 must be 5 rad 2. This next one's similar. Can you figure it out? 45, 45, 90 is x, x, x rad 2. So again, if across from the 45 is 3, this one also must be 3, and this must be 3 rad 2. So across from the other 45, this must be 3, and this must be 3 rad 2. A little more difficult. So I'm going to try and show my work just a little bit better here. So I got my 45, 45, 90 is x, x, x rad 2. This time across from my 45 is 2 rad 2. Let me draw the 2's the same. If x is 2 rad 2, this x is 2 rad 2, and this x is 2 rad 2 rad 2. Do you see I have to add that on? Okay, so I know that across from this 45, b is also 2 rad 2. So what is this? Can I simplify it? Well, we talked about radicals. I can do inside times inside, so that would be the square root of 4. And we know the square root of 4 is 2, and 2 times 2 is 4, so a is actually 4. Okay, the other one is my 30, 60, 90. 30, 60, 90 is x, x rad 3, and 2x. I wonder when this guy got bored enough. Wasn't COVID-19, but maybe a scarlet fever or something. Who knows? But I do know someone was bored and checked every single triangle 30, 60, 90, and this is the relationship. We're going to start back here again with 6. Here, gross. So I've got 30, 60, 90 is x, x rad 3, 2x. Interesting. This tells me the 60 is 2 rad 3. So right here, this is what they gave me. The 60 is 2 rad 3. Now, I don't know if you can see it or not. If you're like, oh, Cooper, x is 2. If you can't, then you would set them up. X rad 3 equals 2 rad 3. Divide by rad 3 on both sides. X equals 2. And then this says 2 times the x, which we just said was 2, which would make that 4. So I know that this is, I wish I could use my colors. Right here, my 90, I know that's a 90, so this one has to be 4. So if this is 60, this guy has to be 30, and across from there, my y is 2. A little bit more difficult. Let's try this next one. We got 30, 60, 90 is x, x rad 3, and 2x. My memory tool to know the difference between these two is because these are the same, x and x, we have 2 in it. This one has a 30, so that has a 3 in it. I don't know if that helps, but here you go. All right. So this one says my 90 is 3. So if I were to solve, this one's not as easy. This one we could see, x is 2, done. Not so simple. So if I have 2x equals 3, and I divide by 2 on each side, I can see that x is, x is 3 halves. And if x is 3 halves, this is 3 halves with a rad 3, or 3 rad 3 over 2. So across from my 60, this is my 60, u would be 3 rad 3 over 2, and across from my 30, v would be 3 halves. Last one, if you want to try it, maybe you just give it a little pause. 30, 60, 90, x rad 3, 2x. So across from my 60, I can see that it's 5 rad 3 over 2. I can see it right away. Can you? If we take away the rad 3 and rad 3, we can see that x is 5 halves. 5 halves, and this is supposed to be 2 times 5 halves. So it'd be 10 over 2, which is just 5. So across from 990, A has to be 5, and the other one, B, has to be 5 halves. Okay, let's keep moving here. So this is trigonometry day 2. So we're going to get into more shapes and things like that. This one is kind of an odd question. You're supposed to like memorize another equation, and I just don't do well with memorizing a ton of things. Instead, I think I'm going to show you a picture of how I handle this. So before we went and got started, I would say, do you know the names of these shapes? 6 sides is hexagon. This is 8 sides. Hopefully you're learning about this in driver's ed. Octagon. And then we have a pentagon. So what I do know is that every triangle, up here, every triangle is 180 degrees. So you're going to see a problem later on in part 2 that's going through this, but we have to figure out what just one angle, if this is regular, meaning all of them are the same, what would this one angle be? So I'm going to walk you through this. What I would personally do is figure out how many degrees do I have. So I'm going to pick that one angle, and I can say I have one triangle, 2. So I've got 1, 2, 3 triangles. So 180 times 4 is 720. And because a hexagon has 6 angles, I can take that 720 and I can divide by 6 and find out that each one of them is 120. Same thing, let's try this octagon. So just go across, do a diagonal from one point, and you can see I've got 1, 2, 3, 4, 5, 6. 180 times 6 is 1.